So we're recording. We're live now, so watch your mouth. I've got the square root of 147. As we talked about last time, it'd be great if this guy were a perfect square, but he's not. So how are we going to break this guy down? Use prime factorization. Start with the smallest prime number that we know, which is 2. But does 2 go into 147?
No.
No. Go to the next one. Does 3 go into 147?
Yes.
How do you know 3 goes into 147, other than the fact that you just typed it into your cell phone?
You add them.
You could add the sorry for the call out. You add the digits. 1 plus 4 plus 7 is 12. Does 3 go into 12?
Yes.
Then 3 goes into 147. How many times does 3 go into 147?
Hypothetically, 49.
Hypothetically, nothing. It just flat out goes in there 49 times. So we could stop here
You can do 7 times 7.
because you know that 49 is a perfect square, right?
Yeah.
So I could stop right here and box this guy. And what does he give me on the outside? The square root of 49 is what?
7.
And then who stays inside the square root?
3.
3 stays inside the square root. Do you all agree? Yes?
Mm-hmm.
So this is all that we have to do for that problem. But let me show you another way of breaking this down. Maybe you didn't see it that way. Maybe you didn't recognize that 49 was a square. But you want to take this guy and you want to break him down all the way to the prime factorization. So we know that it's 3 times 49. And then 49 breaks down how?
7 and 7.
7 times 7. So as we saw in the other videos, there's your prime factorization, right? With the square root, you're looking for one of two things. A perfect square, like we saw here with the 49, but sometimes perfect squares will come in the form of 2 of the same factor, like this guy right here. Right? So if I have 2 factors of 7 on the inside, what does that contribute on the outside?
7.
It gives you 1 factor of 7. And then who's left inside? Who doesn't have another buddy?
3.
The 3, right? So we again have 7 square roots of 3. Do you all agree with that?
Mm-hmm.
All right. Let's try this guy. Maybe make something a little bit more challenging, something you may not see instantly. How about the square root of 48?
Well, we know that 2.
Speak up. We're recording.
We know that it has a factor of 2. We can do the factor tree.
Do a factor tree. We may not know what the largest square factor is that goes into 48. But I know that 2 goes in here. Okay, 2 times what?
24.
And then I keep using the 2 until I can't use it anymore. So then what?
2 times 12, 2 times 6,
2 times 12. 2 can be used again, 2 times 6. And then one last time, 2 times 3. So I see there's my prime factorization. If you go to the prime factorization form of your number, you will not see a number that is a square because prime numbers are not squares. But what you will be looking for will be 2 of the same factor. Do you have that showing up?
Mm-hmm.
You do?
Yeah.
You have 2 factors of 2 here, but you have another pair of 2's right here. Do y'all agree?
Mm-hmm.
So whenever I write this guy, and we did a problem like this on Wednesday, this gives me 1 factor of 2. What does this give me? It gives me another factor of 2, right? Now, notice I put multiplication between these because we know that whatever comes out of the radical is going to be in terms of multiplication because everything we did inside here was written in terms of multiplication, right? When I talk about factors, and I use the word factor, I'm talking about writing with multiplication. So what was left inside the radical?
3.
Now, would you leave your answer like this?
No.
No. How do you rewrite this?
4
So that's going to be 4 square roots of 3, right? And that would be done there. You guys agree with that? Is that the only way that we can work with 48? Sorry.
6 times 8.
You could do 6 times 8. Now, if you do that, you're eventually going to be breaking it down so you get these same prime factors, right? But when we're trying to break these down, you want to think about breaking this down in such a way that you see a factor that's a perfect square. Now, if you know your multiplication tables, your mind might go to 4 times 12, right? Now, what would I think about 4 times 12?
Because you added the 2 numbers.
Well, I didn't add anything.
No, but didn't you say that you could get the 2 numbers and...
I multiply these 2 guys together up here to get the 4.
Okay.
But when I'm trying to break down a number to find perfect squares, I know that 4 times 12 works, but 4 times 12 is a good example because 4 is a perfect square, right? You want a number that goes into 48 that's a perfect square, right? So if I do this, then what does the 4 become on the outside?
4.
The square root of 4 is 4? She's just kidding, folks. That's a 2, and what's left inside the radical?
12.
12. Now, I could box this. It wouldn't be wrong, it's just not right enough. We've been through those situations before, right? Because what can I do with 12? How can I look at 12?
Factor it out again.
How does it factor out in a way where I see a perfect square?
4 and 3.
Yeah.
It factors as 4 times 3, right? And you see that 4 is a perfect square. So what does this 4 give us on the outside?
2.
So it's going to give us a 2, but I already had a 2 there from before, and I've got a 3 left inside the radical, right? So no matter how you do this, you're still going to end up with 4 square roots of 3. You pulled one 4 out as a 2, you pulled another one out as a 2, 2 times 2 is 4.
So you're trying to break down whatever's inside.
Right, and when we say break down, we're breaking down using what operator? Well, I'm rewriting using multiplication, right? So I'm rewriting with factors. Okay. Well, this is the thing I want to point out about rewriting using factors. Well, let me show you one more thing here about the square root of 48, and then I'll talk to you about what I mean with using factors. You can also look at the square root of 48 as being 3 times 16, but here's the problem with looking at 3 times 16. That's not something that usually shows up on your radar with your multiplication tables, is it? That goes just beyond what you're used to seeing, but you will see 48 more, and so you should be familiar with that guy. What's the square root of 16?
4.
That's 4, and what's left inside the radical?
3.
3. So it all works out, right? Now, we should probably use a red pen here so that we know that what's coming up here is wrong and to watch out. The example that I just had earlier on this page had the square root of 147, right? Now let me show you what some people do that's really, really bad. They say, oh, well, I can write this as, that's 144 plus 3, and so the square root of 144 is like 12 and something, and I get 3, so there's my answer. You're looking at me like people don't do this. You'd be amazed at what screwy things people do. And you watching at home in bed may be one of those. Or maybe you're not in bed. It's weird when people watch me in bed.
The fact that you keep repeating it is weird.
No, it's funny because it's creepy. I'm not creepy. Click, add me, follow me, then you're the creeper. So, but there's a problem with this. This is just wrong, right? Just like what I just said was wrong. We can't look at this in terms of addition. And you say, why not? Well, check this out. I'm going to rewrite the square root of 147 to be equal to the square root of 1 plus 1 plus 1 plus 1 plus 1. I could do that, right? According to your way of thinking about things. What's the square root of 1? Plus what? The square root of 1? Plus 1? Plus 1? Isn't that... Wait, what's going to happen here? So this is just going to equal 147?
I don't even know what you're doing anymore.
Well, I don't know what people do here. Mr. Craig, 144 is the largest square. I don't care. I told you to look at it how? Through addition?
Multiplication.
Through multiplication. So you look at it through multiplication or you're screwing up and you're wrong. Right? Because if I do this, that's equal, but that is so not equal. Don't do that. Don't do that. How is the square root of 147 147? Just like on the test, you said the cube root of 343 is 343.
Because they were thinking about the absolute value that you were
Yo,
showing.
hold on there.
I'm just saying that's what we were
Yes,
thinking.
but that's when the index matches the exact power that you have on the inside. But there was no power on 343, was there? Can I get a no snap? And with that, we'll end this video.